At what we are learning today, we are doing part 2. So everything that we learned yesterday, okay, those were our baby steps. Okay, to do a little bit more. So we're doing the same things as we were yesterday. We're just changing up the denominator a bit, and we're going to put some factoring in there too before you get to have your common denominator. So let's take a look at what that looks like. So this is just a reminder, okay? So here's our investigation when we're subtracting fractions, okay? And we did this yesterday. We were talking about finding the common denominator, okay, and then having our strategy. So this is actually, okay, the same thing that we were doing. So yesterday we reminded ourselves, just switch that up, okay. What I do to the top, I'm going to do to the bottom. So in this case, we look at that and say, okay, our common denominator is going to be 8. So we're going to multiply this one by 2, top and bottom, in order to get the denominators to be the same. Okay, and then we had 10 over 8 minus 1 over 8. Okay, and we kind of did this. We recognized that we could write the numerator all together all over the shared denominator. Okay, and then that gave us 9 over 8. And we're totally okay with an improper fraction. Okay. So now the only thing that's really changed is take a look at the example that we're going to do. Okay, the example that we're just going to factor the denominator first. Like yesterday we talked about it, but we didn't actually do it. Today we're actually going to do it. So factor each denominator if possible. So over here, okay, and just the denominators. When we're adding and subtracting, we're going to, because we have to collect like terms, you don't have to factor the numerator because then you'd have to undo it in order to collect your like terms. So just factor the denominator, okay? So in this case, I have a GCF. I can take a 3 out of the first one, okay? And then it leaves me with an x minus 4. Subtract 3 x minus 4, okay? So the thing about factoring is, hopefully, fingers crossed, there'll be some common things with the denominator. So in this case, after I factored it, look, my binomial, what I have in brackets, it's the same for each one. So the only thing that I need to do to make these two have a common denominator is I just have to multiply this one by 3. Okay? Then they'll have the same common denominators. Okay? So I'm kind of getting ahead of myself, okay? Before I do common denominator, guys, state the non-permissible values. Okay, so non-permissible values, I'm okay with the 3 because it doesn't have a variable. So it's just the x minus 4. That part cannot equal 0. So x cannot equal 4. All right, now I determine a common denominator, and we just said that if I multiply the second one top and bottom by 3, then here's what I get. I get 10 over 3x minus 4, and I'm going to be subtracting. 3 times 3 is 9. Okay. I'm just going to pop the 3 in front of. Okay, I'm just moving this to here. That's all I'm doing. So that you can visually see that the denominator is 3 times x minus 4. Okay, so what we usually do is we write these. Okay, we combine the denominators. So we could have just written this as 10 minus 9 all over 3x minus 4. Okay, and then we just simplify. 10 minus 9 is 1. So we have x minus 4. Comma, x cannot equal 4. Okay, so just a note to yourself, okay, we're going to, after we find the common denominator, okay, we can write over one denominator. Yes. Yeah, go ahead. Okay. So once you have a common denominator, you can just combine them, and then you're going to collect like terms on the top. Okay, so let's do a couple examples. See what this looks like. So we're just going to double check. Can we factor the denominator? If we can, we need to. So I'm looking at this first one, and it's just a monomial, so it's already completely factored. Okay, this one here, okay, is a binomial, but it's completely factored as well. So we actually don't have to factor any denominator, so we can go right to our second step, list the NPVs. Okay, so go ahead and list NPVs. So the NPV for this one, x cannot equal 0. NPV for this one, okay, x minus 4 cannot equal 0, so that means x cannot equal 4. Okay, guys, what is going to be our common denominator for this one? Okay, we've got a 2x over here, and we have an x minus 4. Do they share anything in common? No. Okay, so that means that we're going to have to do the full multiply each one by the other one. Okay, so that means that we're going to take this, x minus 9 over 2x, and we're going to multiply it by the other denominator, top and bottom. What you do to the bottom, you have to do to the top. Everybody with me so far? Okay. Then we're going to do the same thing over here. We're just going to rewrite what we started with, and then we're going to write what we have to do to this one. And so our common denominator is going to be 2x and then x minus 4. So this one has the x minus 4, still needs the 2x. So we're going to multiply top and bottom by 2x. Okay, so whatever you do to the bottom, you're going to do to the top. Okay, and now we're just going to combine the numerators. Okay, and collect collect like terms. Okay, one of the things that came up in one of the questions, but we didn't, it was one of the homework questions, but we didn't talk about it in class. Let me just go back real quick because we're going to see it here, and I just want to make sure that we're okay with it. Okay, when we did this question here, okay, so let's just pause. We did this one on the board, okay, but I don't know that you came back and put it in your notes. For this one, okay, when we had our, and I'm going to just write this over here. When we had our common denominator, okay, we said that it was going to be 10a squared. So this one needed a 5, and this one needed a 2a. Okay, so we talked about, right, distributing the number through the brackets. Okay, so this became 5a plus 35 minus 6a, and this was all over 10a squared. Okay, and then you guys remember that we collected our a's. So we had negative a plus 35. You guys did this one on the board, okay? And we even took out the negative sign so that our a was positive, and that made our negative 35 all over 10a squared. Okay, so this part here, okay, where we are distributing the number through, okay, we're going to be doing the same thing for today's question, except now, okay, guys, do you remember FOIL from grade 10? First, outside, inside, last. Okay, that's what we're going to be doing here. Whoops, my arrows look messy, okay? Whoa, what'd I do? Take me back. There you go. Sorry, guys. Okay, first, outside, inside, last. There we go. Okay, we're going to FOIL. So we have to remember how to FOIL. Okay, so when we do the FOIL, we do the two first numbers. So we have x times x is x squared. Okay, and then we do our outside ones. This x times this negative 4, negative 4x. Then we do our inside ones, the -9 and the x. And then we do their last ones. The -9 times the -4 gives me +36. Okay. And then this, we're going to keep the bottom in factored form. Okay, you don't have to distribute anything in the denominator. Okay, just the numerator, because now we have this one, plus 6x squared. Okay, now we're just going to multiply. So we multiply the 2 times the 3 and the x times the x gives us the x squared. Okay, and then from here, now we can collect all of our like terms. How many x squareds do we have altogether? How many x's do we have altogether? And then how many just common numbers do we have? Okay, so our answer here is we have an x squared. 1 plus 6 gives us 7x squareds. -4 and -9 gives us -13x's. Plus 36 all over 2x, x minus 4. Okay, state our MPVs. Okay. Okay, so we're just doing a little bit more with our amazing algebra skills. Okay, so we're going to do the same thing for the next one. We're just going to look at our denominators. First, we're going to say, can we factor them? Okay, 2y plus 5. Nope, that one's factored. Y minus 3, that one's factored as well. Okay, so then we can go right to our NPVs. So we have 2y plus 5 cannot equal 0. Okay, so then y cannot equal -5 over 2. I'm summarizing. Okay, if you want to show the subtract 5 on both sides and then divide by 2. And then we also have our y minus 3. That cannot equal 0. So y cannot equal 3. So now what we're going to do is we're going to write out our first expression. What are we going to multiply this one by, top and bottom? What are we going to multiply by? Okay, the other denominator? Yeah. Okay, so we're going to multiply it by y minus 3, right? Whatever you do to the bottom, you got to do to the top. Okay, guys, it would be, you have to. Okay, and not just it would be a great idea. You have to put brackets around this binomial, okay? Because you're multiplying the whole denominator by this whole other binomial. Okay, so put brackets around it. And then we're going to subtract. Okay, we're going to put brackets around our binomial. And then we're going to multiply by the other denominator, top and bottom. 2y plus 5 and 2y plus 5. Okay, so the denominators, guys, we do not have to FOIL on the denominator. Okay, we can keep it in factored form. The only thing that we're doing is in the numerator, okay, we're just going to distribute any numbers through the brackets. And don't forget, this is a -1 that we're going to distribute through. So don't forget the sign. If there's a negative sign, you're going to take the sign with you. Stop being goofy. Stop being goofy. You can also move. All right. So you should have 4y minus 12 minus 2y minus 5. Okay, everybody have that so far? Okay, so we just multiplied the 4 through the brackets, and then we multiplied the -1 through the brackets. Now we can collect any like terms. We have a 4y and a -2y. So we have 2y, negative 12 minus another 5, negative 17. Okay, just state your non-permissible values. Y cannot equal negative 5 over 2 or 3. Okay, I'll give you a sec to catch up on that. Yes. No, you don't have to. Yep, because the only collecting that we do is on the top. We don't have to expand the denominator at all. Okay? Yep, great question. So you can keep the denominator in factored form. Okay, because there wouldn't be any, the only way that you can, like this, you would just double check, could I factor the numerator, right? And you can't, like you can't take anything out of 2y minus 7. That would, so if you're gonna factor or simplify anything, once you've collected your like terms, you would just say, can I factor that? And if you can, do it, and then you would see if you could cancel. So you wanna keep your denominator in factored form. Okay. All right, let's do the next couple. Okay, so now we have some factoring that we need to do first. Then state your non-permissible values. Figure out what your common denominator is. Okay, so I'm going to give you guys a bit of a head start. I want you to try them. Okay, and then we're going to, then we'll do them together. Okay, give these a try first though. Let me get that. Okay, first thing we're going to do is factor the denominators. This becomes, so this is a difference of squares. So you should have p plus 1, p minus 1. Okay? Okay, and then we can do our, now we do our NPV. So we factored. Second step, NPVs. P cannot equal plus or minus 1. Okay, now we do common denominator. And we look at these and look, they both have a p plus 1. So we don't have to do, so the common denominator, we're going to do p plus 1, p minus 1. So this one already has the common denominator. This one we just need to multiply. Oh, sorry. Let's get the right sign in there. There we go. There you go. P minus 1, p minus 1. That's what it was missing. So you're going to multiply it top and bottom by what it's missing. Okay. So now what we're going to do is when we combine these, okay, we're going to multiply that 2 through the bracket. So we're going to have 4 plus 2p minus 2 all over p plus 1, p minus 1. Okay, and now we just simplify, we just collect, we have a 4 minus 2. So this gets us to 2 plus 2p. Okay, guys, are we done? Not quite. We can do a GCF on top, can't we? Yeah, we can. Okay, so if we do our GCF, we're going to take a 2 out of it, and we end up with 1 plus p. Okay. Is this exactly the same as one of the factors on the bottom? Like, yes and no. If they were just reversed, okay, but they're both positive, so that means this is exactly the same as p plus 1. Okay, so yes, in this case, we can cancel these two. Okay, so our final answer here is 2 over p minus 1. P cannot equal plus or minus 1. Okay, so just take your time, right? Factor, so factor is breaking apart, right? And then we're going to like multiply, we got to do that common denominator. We're going to multiply one or both of our fractions, top and bottom. then we're going to expand, then we're going to collect like terms, and then we might have to factor again and simplify. Okay, so we're going to do the same thing over here. So first we're going to factor. Okay, nothing to do for the 1 over x. Okay, notice it's a subtraction. Okay, so whatever we end up with on the numerator for this one, that subtraction sign's got to go through the brackets, okay, if there's something that happens over there. So just remember, we're doing a subtraction. Okay, we're going to factor the bottom, and we end up with an x plus 2. Okay, we took a GCF out. We just took an x out of both terms. Okay, now we do our NPVs. Okay, what can x not equal? Let's hear it. 0. Okay, thank you. X cannot equal 0, and x cannot equal -2. Okay. What's our common denominator going to be? Yeah. Yeah, we're over here on D. Okay, so both of them already have an x, but this one has an x plus 2, so I got to make the other one also have the x plus 2. Okay, so what that looks like, we're going to do this. Then we're going to multiply what it's missing. Okay, and then -1. I got to start writing smaller. All right. So then when we bring these together, we just have x plus 2 minus 1 all over x plus 2. Okay, so this is x plus 1 over x plus 2. Okay, guys, can I simplify that? Is there anything the same on the top and the bottom? No. Okay, the binomials are not the same. Okay, we cannot cross out. If you were thinking, well, I got an x on the top and an x on the bottom, that's why I put brackets. X is connected to the 1, so that makes it a binomial, and there isn't a matching binomial on the bottom. So then just write your non-permissible values. Okay. Okay, if you're feeling like you got this, go ahead and work ahead. Otherwise, stay with me on this one. Okay, so guys, this one is one of those ones where the terms are right, but the signs are different, right? The signs are switched. Did you need me to just roll that down a bit? Yeah, more? Okay. Okay, so in this case, guys, if I rewrite this, remember, 1 minus x, okay, if we were to rewrite this, okay, we could because I always like my x's first, okay, that's a little bit more natural. That's how we've been taught. So if I just rearrange this, okay, 1 minus x is the same as saying -x plus 1, okay? So remember that we learned that if you take a -1 out of it, you end up with x minus 1, okay, with a negative sign in front. That just flips all my signs inside if I take a -1 out. So this is, okay, like this would be a really awesome thing to make sure that you have in your notes so that when you get to a test question, you can kind of flip back and go, oh, I remember we talked about this in class. So if you don't remember it right away, you can at least reference your notes. Okay, so what I would do is I would, okay, rewrite this question, okay, because now it's going to help me find my common denominator. So in this case, I'm going to have 2 over x minus 1 minus 1 over -x minus 1. Okay, I'm just substituting this, okay, and I'm going to change it for this. Okay, I haven't done anything else. I'm just switching it. Okay, so this is what I've done. I just substituted those. Okay, now the other thing that you need to recognize is by doing so, okay, look what happened. I've got a negative, I'm like subtracting a negative. What is subtracting a negative? What do we change that to? Adding, right? When you have a negative and a negative, so this can be, this is what we have now, x minus 1 plus 1 over x minus 1. Guys, do we have a common denominator? Yeah, we made that one little change. We took a negative sign out. We made that one little change. And now we have common denominators. So now we can actually like do the 2 plus 1 over x minus 1. So that gives us 3 over x minus 1. Oh, what did I forget? MPVs. Okay, so we just, again, we just kind of like pop up to the top, make sure that we get it from the original question, and our MPV is x cannot equal 1.
Can we do the next one on the board?
We can do other ones on the board. Okay, we'll do this one in our notes and then we'll do some on the board. Okay, because I think that's a good thing. All right, so guys, this one I want you to do the same thing that we just did. Okay, I want you to replace this 7 minus m. I want you to like switch them, pull out the negative so that they're the same, and okay, see what you get when you collect your like terms, because now you've just introduced a negative into that second expression. Okay, I'll give you 2 minutes. Back and forth as to what the right answer is. So let's take a look at this. So, okay. So this one we're not changing. M minus 7. Whoops. My book is just touching. Okay. This one. Okay. What we wanted to do is we wanted to switch the m and the 7, right? Change their signs. So yeah, the negative comes out. I'm just going to put it in front of the m rather than behind it so that we could do this. Okay, so just be aware that when we have a negative on the bottom, it trickles up to the top. When it trickles up to the top, it's going to go through both terms. It floats up to the top.
There we go.
Is that better
Yeah.
than trickling up to the top? Does trickle only go down? that analogy, okay? So we have our common denominator. We have 5m plus 1 minus 4m minus 8.
Okay. 1 second, please.
Okay.
Oh, okay, and then you are able to ditch the negative on the bottom.
Yeah.
Now you have common denominator.
Yeah. Yeah.
I see.
So it's like taking that negative 1 that was living on the bottom and just put the negative 1 on the top.
Right, yeah, yeah.
Yeah. Okay, so guys, if you're going to make a mistake on this one, it's going to be forgetting to put the negative through both terms. Okay, and your 8 might not get the negative. Okay, so just make sure, right, like this, guys, this is like a really good test question. Like it's kind of making sure that you're understanding all the things. Now we collect like terms. We end up with 5 minus 4 gives us just m. 1 minus 8 gives us negative 7. Okay, they cancel. And we end up with 1 over m. And our MPVs, m cannot equal 0 and 7. Okay. Okay, our final example before we do some board work. Okay, the subtraction of this expression can be written in this form with A, B, C, and D. Okay, so we basically just need to solve it and then match up our A, B, C, and D. Okay, so this one, it's already factored, awesome. Because it's numeric response, I'll let you get away with not writing the NPVs. Okay, we still need to do common denominator though. So we got to multiply by my y minus 1. It's a subtraction. So we have the y minus 1. We're going to multiply by what we're missing, the y plus 2. Okay, don't forget. Okay, when we multiply, we take the sign with us. Okay, so we have 3y minus 3 minus y minus 2 all over y plus 2, y minus 1. And then that equals 3 minus 1 is 2y minus 5. Let's take a look at our form, make sure that we're in the right order. Our form shows us that we should have the y at the beginning with an a value. We have a negative b, awesome. And then we have the plus 1 first, and then the minus 1. Okay, it's important to check with your form just in case you had, thank you. Okay, just in case you had written them in a different way. Okay, I don't want to lose this. Let's get this plugged in for you guys. All right. My cord. There we go. Oh. Oh, I am plugged in. There we go. All right. Okay, so our A value is 2. Our B value, because it gives us as a negative, our B value is 5. Our C value is the positive 2. Our D value already gives us the negative, so our D value is 1. Okay, guys, don't forget, there are no negatives in numeric response. Okay, there's no negative signs in numeric response. That's why they tell you that there's a negative sign. They take care of the negative for you. So your B value is a positive 5. And then you just have to write in 2, 5, 2, 1. Okay, for your final one. All right, let's go up to the boards. Let's do a little bit of more extra work, and then I'll give you guys time to work on your practice questions.